I hope everybody enjoyed this beautiful cold weather this weekend. Well, today was much nicer than yesterday, but anyway, for those that like winter, there was your time. We are back to limits. Today we are going to talk about limits of functions at infinity, and we will talk about three different functions: power function, polynomial function, and reciprocal function. And then we'll talk a little bit more about one-sided limits. So let's start with the power function. If we think of a power function, the example of a power function could be just a parabola, y is equal to x squared, or y is equal to x to the power of 3. So if you think of a limit, you are thinking about end behavior. So no matter what power it is, as x is going to approach positive infinity, even if you have a parabola, or so x squared or x to the fourth or x to whatever even power is, it's going to look like this. So as x goes to positive infinity, my function is going to go to positive infinity as well. Now, if the exponent is odd, the same thing is going to happen as x goes to positive infinity. The function is still going to go to positive infinity. This is going to change as x is going to negative infinity, because again, we know that what the behavior is like. So if the n is even, the function is going to go to positive infinity. If the n is odd, the function is going to go to the negative infinity. So here's an example. If I want to find the limit as x goes to negative infinity of x to the power of 5, what would that be equivalent to? Well, this is the odd number, and I want x to approach negative infinity, so I know that this is going to be equivalent to negative infinity. What if I have another example? I'll call this as my A, here's my B. Limit as x goes to negative infinity, what if I have x to the power of 6? Well, this is the even exponent, so the behavior of the function will look like that. So I know that this is positive infinity. This is going to be important also for the polynomial function. So let's take a look at the definition. I will post those notes so you can look at them and then follow them that way. Polynomial, so if you think about this, you can have some kind of coefficient and x to whatever power plus, and this pattern will continue. We'll have plenty of polynomial examples here. But whatever your polynomial is, the limit as x approaches positive infinity is going to be equivalent to limit of the term with the highest exponent along with its coefficient, and I will show you what to do with the coefficients in a second. And then the same thing is going to happen when you are looking at the limit as x approaches negative infinity. Where is this bringing us? This is bringing us to what the limits were for the power function. So let's take a look at examples. If I have limit as x approaches negative infinity of this polynomial, this is going to be equivalent to limit as x goes to negative infinity of the term with the highest exponent. And the term of the highest exponent is to the third power. And because this is an odd number, I know that this is going to go towards the negative infinity. You can graph this polynomial, and this is also going to show. So that's how you algebraically can find it. Let's take a look at the next one. Limit as x approaches positive infinity. I need to figure out which one is the highest, or the term with the highest exponent. And notice this is negative x to the power of 2. Whenever you have any number, in this case we know that we have -1, you are going to bring this negative in front, and then you will have limit x approaching positive infinity of x squared. So now we have negative number multiplied by, as x approaches positive infinity, if we have x squared, we know that this is going to be infinity. And if you multiply positive infinity by -1, this is going to give you negative infinity. As a different explanation, let's think about this for a second. If I have negative x squared, I know what the graph would look like, and I know what the end behavior would be. But this is how to show it algebraically. Let's look at this one more time. I am looking at limit as x approaches negative infinity of this polynomial. This would be equivalent to limit as x approaches negative infinity of just 5x to the power of 4. Well, we could bring 5 in front, and then limit as x approaches negative infinity of x to the power of 4 is going to be positive infinity. And positive infinity multiplied by the positive number is just the same. So here we go. Again, you are thinking about the end behavior of the function when you are checking what's happening when x approaches positive or negative infinity. Another one is a reciprocal function, and as a matter of fact, that goes a little bit farther than just f of x is equal to 1 over x. If you think of the rational functions in general, and you think of the horizontal asymptote, if the exponent on the top of the fraction is bigger than the highest exponent on the bottom of the fraction, the horizontal asymptote is always at 0. And the horizontal asymptote is whatever your limit is. So if you have something that looks like this, your limit is always going to be 0. As a matter of fact, let's write a couple more examples. Limit as x approaches negative infinity of 1 x to the power of 2. Well, we could graph this, or we could think about this. What is the horizontal asymptote for this? Horizontal asymptote is at 0, so this is going to approach 0 as well. So that's that. I will give you a good amount of examples where you can practice this. Use your notes if you need to, or think about the end behavior. You can also graph those functions just to check your answers. If you don't have a graphing calculator, you can use Desmos on your computer or on your phone, and it works really, really well. All right, one-sided limits is the next thing that I want to talk about. Well, we've already discussed this looking at the graphs, but I just want to remind you that a limit that is evaluated at x approaches the value x is equal to a from one side only, can be left or right, is called a one-sided limit. So notice that we may have a one-sided limit, and again, as x approaches some number from the left side, or as x approaches some number from the right side. And when those two limits are equivalent, then we can say that it is a two-sided limit at that point. If they are not, the two-sided limit does not exist. Again, there are two methods of doing this, of finding the limits. And notice I have one example, and we can approach this example in two different ways. Well, some of those examples we can just try to plug in 2. Let's see what happens. 2 times 2 is 4. 4 plus 2 is 6. Minus 6 is 0. Well, that's problematic. So what you could do is you could make a graph of this, or you could hope for the best. I know that some of the problems that I assigned for homework would work with factoring. Well, let's see, could we factor it nicely? Can we find two numbers that multiply to -6 and add up to 1? Those are +3 and -2. +3 times -2 is -6, and then they do add up to 1. Let's see if that helps me with anything. X plus 3, x minus 2, x plus 3. Well, notice, even though this simplifies, when you plug in 2, you still have that problematic term where you would be dividing by 0, so that really does not help. So here, if something like this happens, we really need to look at the graph. And you would have to get the graphing calculator, and you would have to graph the graph to see what is happening. Again, when you have problems like this on a homework, you can always go and find Desmos. Notice I let myself take the graphing calculator from school and before we left. So I have one, and we'll see what happens when I graph it. I have x plus 3, and then I have x squared plus x minus 6. And if I graph this, I will see what is happening as x is approaching 2 from the left side and 2 from the right side. So notice the 2 is right in here, and I know this because I know that this is a vertical asymptote. So because of this, I see that this would go to negative infinity. So as x is getting closer to 2, the y values are getting lower and lower. And then on the other side, as x is going towards 2 from the right side, this is going to positive infinity. I'll move my calculator away. And then because of all that, the limit at the point does not exist because they are not the same. So we did discuss this a little bit, but just looking at the graphs. Now we'll try to show it algebraically, or a little bit more algebraically than before, okay? The graph is not going to be given at some times. All right, make sure you have fun with the homework assignment. Come see me during my office hours if you need any help, or we can just do it together. I can explain it a little bit better maybe then. Otherwise, have a great day.